Topic for this video, solutions. The essential questions are, what is a precipitate and how do you recognize a precipitation reaction? So I know a lot of you see precipitation, you think about weather, like rain, snow, things like that, but it actually has a different definition in chemistry. So a precipitate is an insoluble solid start falling down, and so here's some pictures of that happening. In both of these cases, both liquids were clear, and when they mix together, they make a color, and you can see it sinking because it is a solid. So that's what a precipitate is. To help you remember, you can think about that it's raining solid, because I know you think about rain with that. So raining solid is what it means in chemistry. So on the back of your star chart, you have a list of what things are going to be soluble in water. So this is kind of a confusing list, and we'll do this actually in class, but just to show you, these compounds are soluble in water. Now, if they have an exception listed over to the right, then those things will be insoluble. For instance, if we look at the last one here, SO4-2, sulfate. If it's combined with strontium, barium, lead, or mercury, so these four exceptions, it's actually not going to be soluble. But if it's combined with anything else, it'll dissolve in water. Okay? The other portion of this that's soluble is over here. Okay, so on the bottom left, they list insoluble compounds. On the bottom right, they list the exceptions. So that means if these things are combined, then they will be soluble and they will dissolve in water. So for instance, let's just look at the first one, CO3 2-, that's carbonate. If it's combined with ammonium, NH4, it's going to be soluble. If it's combined with any of the alkali metal cations, anything from that first column, it's going to be soluble. However, if it's combined with anything else, it's going to be insoluble. So that's how you read that, and we'll practice that in class. Okay, so we're going to look at precipitation reactions, and there'll be double replacement, which we haven't talked about much, but basically the positive switch places, or you could say the negative switch places. So let's do a practice problem, and you'll see what I mean. We mix solutions of lithium hydroxide and copper 2 chloride to produce lithium chloride and copper 2 hydroxide. So the first thing I have to do is write on my formulas, and I do want to make sure that they've been balanced out, to do my crossover and everything. I'm not going to worry about balancing the actual equation right now, though. Okay, so I'm taking little pieces from that chart I showed you a minute ago. And so with chlorine, it is soluble unless it's combined with silver, lead, or mercury. Okay, the other one we're looking at is hydroxide. It is insoluble unless it's combined with ammonia, the alkali metal cations, calcium, strontium, or barium. So if I look at this again, LiOH. So that's an OH, but lithium is an alkali metal. So that is going to be ionic and it's going to be soluble. Okay, if we look at CuCl, and it should be CuCl2 when we're done, but we're just looking at the combination right now. I know chlorine's soluble unless it's combined with silver, lead, or mercury. Well, this is copper, so this is going to be soluble also. Okay, so then we have the other side. Lithium chloride is soluble because chlorine can bond with anything besides silver, mercury, and lead and be a soluble substance. But if I look at copper hydroxide, I look at OH is insoluble, and I look at all the exceptions. Copper is not one of those exceptions. So this is going to make a precipitate, and that's how you figure that out. So we'll do a couple more practice problems. Mix aqueous solutions of ammonium sulfide and cobalt 2 bromide to produce ammonium bromide and cobalt 2 sulfide. So here's ammonium sulfide, and I'm not going to do the crossover right now, but you would of course need to if you're writing a full equation. There's cobalt 2 bromide. Okay, there's ammonium bromide, that's what we're producing, and cobalt 2 sulfide. Again, I have not done all my crossovers, and you would want to do that. I'm just showing you how to find the precipitate. So again, I'm stealing from that chart. With bromine, it is going to be soluble unless, here's my insoluble exceptions, it's combined with silver, lead, or mercury. So if I look at both bromine options, it's not combined with any of those. So that's going to be soluble. Okay, and we're actually not even going to worry about the stuff on the left-hand side of the equation. Okay, so here's the other part. So sulfide is insoluble unless it's combined with ammonium, alkali metal cations, calcium, strontium, or barium. So I look and it's combined with none of the above. So that's going to be insoluble, which means that you have a precipitate. Alright, let's look at the next one. Mix aqueous solutions of silver nitrate and sodium phosphate to produce silver phosphate and sodium nitrate. So there's my silver nitrate combo. There's my sodium phosphate. Again, I have not yet crossed over. There is my silver phosphate and my sodium nitrate. So now I can pull off of the periodic table. This NO3, 1- is soluble, and there's no exceptions to that. So anything combined with NO3 is going to dissolve in water, which gives this a soluble mark. Okay, the other part is PO4, and it's going to be soluble, it's going to be insoluble unless it's combined with ammonium or the alkali metals. Well, if I look at, again, I'm only going to look at the right side of my equation. If I look at Ag3PO4, that's not one of the combinations, it's an exception. So it's going to be insoluble, which means that that's a percent.